In the last session, we studied about linear probing with chaining, right, where the synonyms are chained by us so that the comparison will be done after we get the start of the chain. We can only compare with the own chain elements instead of comparing with all the elements till empty location. Only the comparison is done with own chain elements. It is same hash value elements. Okay. So chaining is it improves our searching. So in chaining, we use hash value as an index to the array and one more field pointer which is chain it is added into this hash table. Each pointer accesses a chain of elements that share same hash location. Okay, so same hash value elements will be chained together. In chaining without replacement method, so chaining will have to, again, linear probing has two types of algorithms, which is without replacement and with replacement. In without replacement, we maintain list of items which collide with an existing items. That is, colliding records are chained together to other locations. So other locations are also possible. That means I can start if location 2 is not available and my hash value is 2, I can start the chain of 2 at another empty location. So it is not guaranteed here in chaining without replacement that same hash value will element will start at that particular location only. It can start at another location also. So when we want to search, first check that the original, uh, so we start at original location, but if it is already occupied, then we check what is the hash value of that particular element present there. If it is the own chain element, we access the chain. Otherwise, if another chain element is present there, then we have to search for the start of the chain. Okay. And once we get the start of the chain, then only the same chain elements will be compared. Okay. This is the case in chaining without replacement. So example here, already suppose these two elements are present with hash value 3. So first hash value 3 element will be at own location 3. Next element which is with hash value 3 is uh, it is written at location 4. So if location 4, that hash value 4 element comes, then its own location is actually 4, but here already another element is written. So this element 19004, it is written at the next empty place. So replacement will not be done. Okay. So chain of 4, instead of starting at location 4, it is now starting at location 5. So here we need to search for start of the chain first. And once we get that chain, then only that chain elements will be compared. Okay. So in chaining with replacement, uh, in order to avoid the difficulties in the previous method, which is chaining without replacement, this method is used where we can guarantee that every chain is starting at its own home location. Okay, so we do the replacement. In this case, if this value comes 19004, then 18003 it will be replaced to the next empty location, that is at location 5, and 19004 will be written at that location. Okay, so we are sure here no need of searching for start of the chain. If the chain is present, it will be present at its own location. Okay, so searching will be simplified. Only same location elements will be compared in this case. But it complicates our insertion a bit because of that replacement. Okay, so in the previous example, if suppose original value comes, then it is kept at next available location. Whereas in chaining with replacement, if we want to insert this particular value 15004, then its proper location is 4. So this value is kept at proper place, and 18003 it is shifted to the next available location. Okay, the difference is clear between chaining with replacement and without replacement. So what is the overall problem of linear probing? It tends to clustering. Okay, so the large clusters are formed. That's why surging complexity will increase, because cluster means uh, in worst case we are going to compare with all the elements of that cluster until we reach to the empty location. Okay, so if there are no empty locations or very few empty locations, that means lot of clusters are there. Okay, so elements tend to cluster in dense intervals in the array, so this will complicate our searching. So before going ahead, I want everyone to solve this particular example before we look other methods of collision handling. I want that everyone should solve this example by your own, so that you will come across different cases. We have to create a hash table and insert the values in this given sequence. First method used for handling collisions is linear probing with chaining without replacement, and second method is linear probing with chaining with replacement. Okay, so you have to create two hash tables. In first, you will be inserting the elements by following that with chaining without replacement algorithm, and in second one, you will be following linear probing with chaining with replacement. Okay, and check uh, what are the hash tables created. Okay, everyone do that and tell me what is the final hash table which you have created. Within 5 minutes, complete this assignment. I want everyone to solve the problem. And if you are facing any query or doubt, you can ask immediately. Okay, until and unless you do it by yourself, you will not be clear with the logic. And we have to implement both these methods in our assignment. Okay, we have to write the code for this. So until and unless the logic is clear, there is no point in writing the code. Tell me what will be the size of the table. What will be the size of the table? The hash function is given key mod 13. What size you will take? 13. Correct. So 0 to 12. So first step is calculate hash value of every element, every key which you are going to insert. Okay, that will help us in inserting or checking for the home location immediately. Initialize the flag to 0 for every location. Initialize chain to -1. I want everyone to solve the example. This is the empty hash table which we have to create initially, where every value will have 0 for flag and -1 for chain. Okay. And for all these keys which we have to insert, we will find the hash of it, so that we will come to the exact home location. 22, 1, 22, 45. First step is you have to calculate hash of every key and then decide. So depending on whether that particular hash location it is empty or occupied, you have to decide where you will be copying it. Okay, so it depends on the sequence which you are entering. In what sequence you are entering these values. If you use another sequence for entering the values, you will get different hash table. Okay. This is the key and the hash. Check the hash values whether they are correct or not. Is there any correction in the hash value? Are they correct? Shall we go ahead? Please cross check. So first value at location 5 it is empty inserted. And this is the first element at this location. So single element of hash value 5, that's why chain value will be -1. This is first and last element of this chain. Then 41 with hash value 2, 22 with hash value 9. Next is 44 with hash value 5. Collision happens, and here same chain element is present, hash value 5. So next location is searched and 44 is written there, and these values will be chained together. Okay, this is the next element of the same chain. So here the chaining will be done. Okay? Because at location 6 we have written 44, so 6 will be copied here in the chain of the previous element. Then next is 45 with hash value 6. Now 6 is occupied but with hash value 5 element. Okay, one chain element is not present. So next empty location is searched and we will copy 45 here. This is chaining without replacement. That's why 44 will be present at the same location. It will occupy same location 6 and 45 will be returned to another location. Okay. So we will not replace 44. Even if it is having another hash value 5, it will be there at location 6. Okay, and 45 with hash value 6, it is returned to another location. And this is the single chain element of that particular hash value 6. Okay, are you getting these conditions? Then 59 with hash value 7, again 7 is occupied with another hash value element, so 59 will be stored here. Okay, and it is the single element of chain 7. Then 32 with hash value 6. Hash value 6, this is occupied but with hash value 5 element. So we need to search for start of the 6, hash value 6. We'll go to the next location. So hash value 6 element might be present here. Okay, from on home address location, that is 6 to the empty location. In this particular cluster, we might get the hash value 6 chain. Okay, so we will be searching for the start of chain of 6. So we will move to the next location, location 7. Check here whether we are getting the hash value 6 element. Yes, the hash value of this element and the current element is matching. Are you getting? And then we will check. We will follow the chain, but in chain we immediately get -1. That means this is the single element of hash value 6. Okay, so we will keep reference of the start of the chain. This is start of the chain as well as end of the chain also. Okay, and suppose we will store it in a reference P, end of the chain. Okay, and we will move ahead and go till the empty location is obtained. Empty location is obtained here. So we will insert 32 at this location, and we will modify the chain of previous end of the chain. Okay, so whatever is our empty location, that reference will be given here. Okay, so there are now these elements in chain of 6. This is one element, and at 10, location 10, there is another element, and this is the end of the chain. Are you getting what we are doing? Then next is 31 with hash value 5. If anyone is having any problem, please ask. Okay. Now, location 5, it is occupied and it is having same hash value element present. So we will directly start accessing the chain. Okay. Next chain element is at position 6 and this is the last element. So these are the two elements of the same chain of 5. So we will keep the reference of the chain in a variable, suppose P. End of the chain we have stored. Okay. This is start of the chain and we access the chain till end of the chain. Now we move ahead and compare each location, and here we get the empty location. So we will store 31 at this location. Okay, 31 will be stored at this location and its reference, the location reference will be given here where we have kept our P. Okay, so now there are three elements of chain 5. This is one, this is another at location 6 and another at location 11. Okay, next is 73. Its hash value is 8. It is already occupied but with different hash value element. Isn't it? It is hash value 7 element. So we will be searching whether hash value 8 element is there or not by comparing with all. But there is no hash value 8 element found here. Okay, so chain of 8 will start at this location. 73 will be stored here. Okay. Then next is 57 with hash value 5. Again go to 5, it is already occupied. And these are the elements of hash value 5. Okay, 11 also. Then 57 will be stored. This will be our P, that is end of the chain. And 57 will be stored in the next empty location, that is at position 0. And it will be chained also here. the chain of end of the chain, that will be modified to 0. This will be the last element of the chain of 5 now. Then 58 with hash value 6. Hash value 6, it is not present here. 6, chain of 6 is starting here at location 7. So we will access this chain. Then it is the last element of the chain of 6. This will be our P. Search for next empty location, it is here. And 58 will be returned here. Okay, and chain of this will be modified to 1. The next is 23 with hash value 10. Hash value 10 is occupied, but its hash value is different. Then we will search whether there is hash value 10 element present or not. We will compare with all these till empty location is accessed. Okay, and we will check whether hash value 10 element is present or not. No. Okay, so chain of 10 will start here. Okay, and 77 with hash value 12, that is also occupied, but another chain element is present. So we will search, compare with all these elements and check whether hash value 12 element is there or not. But no element is there with hash value 12. So 77 will be inserted here. Is it clear? Chaining without replacement algorithm will implement the same for chaining with replacement. We will create a hash table for chaining with replacement algorithm as well, and we'll check what different values we will get. This is chaining without replacement. I will create another hash table here which will follow chaining with replacement algorithm. Okay, so initially this is also empty. The flag will be 0 for every element and chain will be -1 for every element. This is our empty hash table. Now we will start following the algorithm chaining with replacement. Okay, and insert the same keys. So 18 at hash 5 it is empty, so 18 will be inserted. 41 hash value 2, then 22 with hash value 9, and 44 with hash value 5. Hash value 5. So 5 is occupied with same chain element 5. So it will be chained. This will not get replaced because one chain element is present. So replacement will not happen. Okay, but if another chain element is present, then we have to replace. Then 57 or 59 with hash value 7. So 45 with hash value 6. Yes, now the collision is there and another hash value element is present. So we need to replace this 44. Okay, but replacement is not that easy. Here another hash value element is present. So we will replace it to another location. But someone is pointing this element. It is part of chain of 5, isn't it? Someone is pointing this element. So we need to update this also. Okay, so when 44 it gets replaced to another hash, another slot, then here we need to modify the chain value also. That empty slot, first of all we have to search what is the hash value of this 44. It is 5. So we will access the chain of 5 till end and we will modify its location. Okay, whichever element is pointing to location 6, now it should point to location 7, that is next empty slot location. Like this we have modified this chain. Okay, shifting is not that easy. We have to replace it and then we will be inserting 45 at this location. Clear? Is the replacement clear? If you are not getting, see, you have to do all this in coding also, in program also. Then 59 with hash value 7. Again the collision is there and another hash value element is present. So we need to replace this again. Okay, 44 needs to be replaced again. So 44 will be replaced to the next hash location, but its replacement will hamper this chain. It was being pointed by this chain 7, and now it will point location 8. Okay, and here we will store own chain element, that is 15. Right? Is the insertion clear up to now? We'll go ahead. 32 with hash value 6. 6 is occupied and it is having own chain element. Okay, 45 is also having same hash value 6. So 45 will not get replaced. Okay, and 32 will get copied here, and the chain of this, because this was the last element of the chain, so it is get modified to 10. Then 31 with hash value 5. 5 is already occupied with hash value 5 element only. So we will access this chain till end, because we are going to insert one more element of hash value 5 in the chain. So we need to access the chain. Okay, so chain of this will be checked. This is the end of the chain. This is start of the chain. I'll say S start of the chain, and this is the end of the chain. 18, 8, this one. Okay, this is end of the chain. Marked by P. Okay, and now we have to insert this 31. So next empty slot is accessed after this, and 31 is present. It will be copied here. So chain of this will get modified to 11. Because we have inserted one more element to the same chain at location 11. Then next 73 with hash value 8. Okay, hash value 8 it is already occupied. Okay, now see this particular thing, because see we are replacing the hash value 8. We want to write here hash value 8 element, and this is already having element with hash value 5. Okay, and now this is being pointed by this element, and it is also pointing to another location. Are you getting? So this is the middle element of the chain. This is not the start or the last element of the chain. As we know, suppose assume that this is a linked list. Okay, assume that this is the linked list of suppose first element as 18, which is pointing to the location 8, and here we have at location 8 again. So this is second element of the list, which is 44, which is pointing another location 11, and at 11 we have the third element of the chain, which is 31, and this is end of the chain. So imagine this is as a single linked list. Okay, so what we were doing up to now, we were uh, replacing this element, which was last element of the chain. Okay, so it will only hamper this particular value. If we are replacing this, then this will only hamper this value, isn't it? So instead of 11, it will point wherever we are replacing it. It will point that location. But now we are going to replace this. Okay, so how this replacement will take place? How this replacement will take place? We have to shift this to the end of the chain now. We have to remove it from here. Okay, we have to remove it from here and place it at the end of the chain. Here. Okay. That is what we want. Because we want to make that slot free for storing another value. Okay, now what elements will be changed? So I'll show that replacement here. So this will remain as it is. Sorry. This is location 8. This is location 11. So if we want to replace it and we are going to store it at some another location here. Okay, so we will be removing this from here and we will be keeping it at the end. Okay, and now this 18, instead of pointing 8, it should point directly 11. Okay, so this will get changed. Instead of pointing this 8, it should directly point to this 31 element. Okay, because 31 will be at this place. And this 31, instead of, as this is not the last element, this is pointing this particular element at location, suppose 12. Okay, we don't know what will be this empty location, we'll see that. But whatever is the location, empty slot where this is shifted, this 44 is shifted to this empty location. Okay, so 31 should point now that location. It will not be the last element now, it is middle element. And this one is the last element, so this will be the -1 value. This replacement of this middle element, it has hampered the previous location. Okay, this previous location as well as the next location, this. Okay, and as this will be now the end element of the chain, this will be the last element of the chain, so this is also changed. So in order to shift this 44 from here, okay, we will be replacing 44 to this location, but while replacing, what we have to do, we have to modify the this value 8 with whatever value is present at this location. It was 11, so 11 will get copied here. Okay, and then we can replace this 44 from here to the location 12, and the last element of this 31, last element of the chain, this will now point this element, so this will also get modified to 12. Okay, and now we can write the value there at location 8. We can write this 73 now after shifting is done successfully. Okay, are you getting? So now the chain is changed to 18 pointing 11. 11 location is having 31. It is pointing 12 and 40. Okay, so these are the three elements of the chain. Is there any problem in the replacement part? Is it clear, the replacement? Yes, you have to write the code for all these statements afterwards. You have to do the shifting properly. Clear? Imagine that this is a list like this, and then you have to replace this particular element at the end. Okay, from middle you are bringing it to the end. Clear? So 18, instead of pointing to this element, it will directly point to this element 11, and 11 will be having reference to the next element, which is this one. Okay, we'll go ahead, insert next value 57 with hash value 5. Hash value 5 is already occupied with hash value 5 element only. So access the chain 15, 11, then it is pointing 12. Next empty location is this, and here we can write 57 and modify the chain of the last element, which is this one. Okay, chain of 5, last element of chain of 5, which is this one, it will get modified to 0. Then 58 having hash 6, hash value 6 is having elements 45, 13, 10, 32 is the last element of the chain. So copy this at the next location and modify the chain of the end. This will be modified. Okay, then 23 with hash value 10. Now hash value 10 element, it is occupied by another hash value element. Okay, so another again shifting will be done. Hash value of 32 is 9. Oh, sorry, hash value of 32 is 6. Isn't it? It is 6. So we have to replace this element to the next location. And this value 10, location 10 is being pointed by this. So we need to modify this also. We'll mark this. We need to modify this as well as this is pointing someone at location 1. Okay, so we need to modify all these things. We have to again shift 32, which is middle element of chain 6. Okay, so 32 will get shifted here, here, and see, it will directly point location 1 element. Okay, which was pointing 10. Now it will directly point the next element of the chain, which is at location 1. Okay, this element. And this is the last element of the chain, which should now point this 32 because we have written 32 at the end. Okay, so it will point location 3, which is the next element of chain 6. Okay, and this location will be empty now, which will have value 23 return. Okay, and next is insertion of 77, which is again having hash value 12 and it is occupied with hash value 11 element. Okay, so replacement of this should be again done. And while replacing, we have to see, this is having hash value 44 is having hash value 5. So we have to replace this hash value 5 element. 18 is pointing 11. 11 is pointing 12. Okay, so this element needs to be shifted. 44 will be shifted here. And while replacing, this will directly point instead of 12, this will directly point next element of the chain, which is present at location 0. And this is the last element of chain, which will point to current element, which is shifted at location 2. Okay, so this will point 4. Now this is key which we can uh, use for copying 77, the own hash value element. So here we can guarantee if the chain is present, it will have it is present at its own location. It will start at its own location. Okay. Any doubt here? Shall we move ahead? So this is linear probing. All these are the linear probing. Then we have seen with chaining. How linear probing can be used with chaining and with replacement without replacement algorithms also. Okay. To practice some programs or some examples so that you will come across these different conditions. And in order to search the elements, how many comparisons will be done. So again, we have to calculate hash and we have to access the chain, own chain elements. Okay. In chaining without replacement, we will have to search the start of the chain, and then after the chain is obtained, we will compare with own chain elements only. Whereas in chaining with replacement, we will be only comparing with the same chain elements. Okay, that will be the difference. Then quadratic probing, like linear probing is in the own hash value we add 1, 2, 3 like that. Here we will be adding 1 square, 2 square, 3 square like that in order to get the next location, next possible location. So key is stored if the location is empty. This hash value location is empty. T, then it is directly placed at that location. But if collision happens, then you have to calculate the next possible location using these conditions, this formula. T plus 1 square mod n. If that is also occupied, then calculate T plus 2 square mod n. Like that. Okay. So next position will be obtained with this until we get the empty location. Okay. So if this is the hash table, these are all locations and these are the values which are there in the table. Then if I have to store 65, the hash value of 65 is 5 and 5 is already occupied. Okay, 5 is already occupied. Then 5 plus 1 square mod n, that is 6 mod n will be done. 5 plus 1, 6. 6 mod n, that is 6. That is also occupied. Okay, then the next uh, calculation will be done. T plus 2 square, that means 5 plus 4 mod n, that is 9. Location 9, it is also occupied. The next calculation will be done. 5 plus 9, that is 14 mod n, and 14 is free. Okay, so the value 65 will be written at 14. Are you getting how quadratic probing is applied? Okay, so 65 will be written here. 65 will be written here at location 14. And you can try inserting all these locations, all these values, all these keys in the table. Please try inserting all these elements in this table. 29 is also shown. 29 is having hash value 14, but 14 is already occupied with this 65. So this following chaining, it is following without replacement. Okay, quadratic probing without replacement. So next value is obtained. It is having T plus 1 mod n, which is this 0, and it is 3. So 29 will be written at location 0. Similarly, tell me where these elements will be stored. What will be the locations of these elements, 4 elements? Yes, 16 will be stored at which location? 16. What is the hash value of 16? It is 2, which is already occupied. Is it 2 or 1? 1. Hash value is 1, which is free. So 16 is written here. Then 14. Hash value is 14, it is occupied. T plus 1 is also occupied. T plus 4, 18. It is hash value 4. It is free. So 14 will be written here at location 4. Then for 99, check where 99 will be stored. It is having hash value 9, which is occupied by 129. T plus 1, it is 10. 10 is also occupied and 11 is also occupied. So tell where 99 will get stored. Is it clear how to calculate that probe value? 13. We will check. Yes, 99 will get stored at 13. And 127, where 127 will get stored? Hash value of 127 is 7, which is 3. So directly it will get stored. No, it is 7. Location 7, which is free. It is not 8. Here. One. Hash value 7 is free, so it will get stored. So quadratic probing advantages, it tends to distribute the keys better. Okay, it distributes the keys evenly through the array, and which was problem in linear probing, that formation of clusters, that is removed to some extent, because see, we are not searching for the next empty slot and immediately inserting, so that will enhance our structure, that will make our cluster bigger in linear probing. Whereas here, if one is not free, we will calculate 1 square, then 2 square, 3 square, like that. So we are jumping by some locations. Okay, so this will spread the keys better, alleviates problem of clustering. Okay, so better distribution of keys than linear probing. Is quadratic probing clear? Next method for handling collision is double hashing. Okay, double hashing, where two hash functions will be there. First hash function is our own, which will calculate the home location, and second function, hash function, is there to calculate offset. Okay, by how many locations from home location we should go ahead, that will be done with this offset. So while table of probe is occupied, probe is equal to probe plus offset mod m. Okay, that offset is calculated based on another hash function, and when we get the empty location, we will store the key there. Okay, and most of the time this m should be prime. We will examine every location. So this, whenever this m is prime, that is size of the table, it will be prime, that will be bit. Okay, and example of this is first hash function k mod 13. So this will be size of the table 13. Okay, k mod 13, it will take us to home location, and if that is occupied, then second hash function will be applied. The offset will be calculated using this. The function, general function for this is, instead of 8 we might have another value, so 8 minus k mod 8. Okay, this is the general function of the second in order to calculate second hash. Okay, so this should be 8 should be less than, in any value which is less than size. Okay, so like that we can form our second hash function. So let key x be stored at element f of x is equal to t. T is the home location. Okay, and we have to define the second hash function f2 of x. Attempt to store the key in the elements for t plus d mod n. D is the offset, which is calculated using another hash function. Then if this is also occupied, we have to say t plus 2d mod n, then t plus 3d mod n, like that. Okay, so we have to calculate the offsets accordingly, or the probe values accordingly. until we find the empty slot. Okay, so typical hash function, second hash function is of this type, r minus x mod r, where r is prime less than size of the table. Okay, so instead of 10, instead of 8, we can imagine of 7. 7 minus oh, 7 minus here 7 minus k mod 7, like that. We can have the second hash function. So suppose we have to insert the values in the hash table using double hashing. Okay, collision removal will be done using double hashing technique. Then, and we have to store 65. So hash value of 65 is 5. The size is 15 here. Okay, so hash value will be 5, and we will check whether 5 is empty or not. But 5 is occupied. 5 is occupied by this. Yes, 35. All these elements are present. Here, in order to store 65 now, collision happens here already the element is present. So we will calculate D for it, which is D is 11 minus X mod 11. So 11 minus um, so value of D is 1 because value of X here. T is 5 home location and f2 of X is equal to 11 minus X mod 11. So f2 of 65 is D, which is 1. What is X in this case? What is X in this case? Are you getting
65, ma'am.
it? 65. Okay, 65 mod 11 is 10. Yes. 65 mod 11 is 10. So 11 minus 10 is 1. Okay. So D is 1. And we have to visit home location, that is T plus 1, then T plus 2, T plus 3, like that. Okay, until we get empty location. So here it is giving us similar to linear probing. As D is 1, that means it is similar to linear probing. But D can be another value also, okay, which we will be adding every time. Fine. So in this case, D is 4 because it is 29. 29 mod 11 is giving us 29 mod 11 is 8. Oh, not 8, it is 7. So 11 minus 7, which is 4. So what we will do, we will visit home location of 29, then home location of 29, which is 14. If it would not be free, then we will be visiting 14 plus 4, 14 plus 8, like that. All those locations in order to find the next empty slot. Okay, so for every value that D will be different. Okay, this D will be different, the second hash value. Is it clear? Try inserting all these values. First of all, you need to calculate the home location as well as this offset. Okay, the D value of D. For 16, home location is 1, which is free. So insertion will be done at that location. No need of D at that point. Then next is 14, it is occupied. So D for 14 is 14 mod 11 is 3. So 11 minus 3 is 8. So if this is occupied, we have to add 8 in this. Okay, that is 22 mod 22 mod 15 we have to do, which is location 7. Okay, if that is also occupied, we have to add uh, again 14 plus 2 into D. Okay, that is 16. 14 plus 16. Like that, we will be searching for the next locations. For 16, D is 6, but this is already free, so no need of D. Then for storing the value 14, we have to do initially T plus 8, but that was also not occupied. That was also occupied, so T plus 16. This was the next attempt. Okay, T plus 8 was already occupied, so T plus 16 we did, and that was free, so 14 is written here at location 0. Then next is 99. For this, we will visit this as home location, it is occupied. Then this will also be occupied, 35. Okay, the next. D for this 99 is 11. That's why T plus 11, T plus 22, T plus 33, all these locations will be accessed. Yeah, until we get the empty location. Is it clear how the probe values are calculated in? Yes. So probe values, how they are calculated in double hashing, we have to select another hash function and the multiples of that offset, which is calculated with the hash function that will be added here in home location. Okay,
Hello,
so
ma'am.
yes,
11 is constant. Is 11 constant there?
yes, it is another 11 means it is selected according to it should be less than whatever size we have, and generally it is prime.
Okay.
Okay, so generally it is prime less than whatever size we have of the hash table. Okay, like that we select the form our own hash function. Clear? So double hashing also it will try to distribute the keys better than linear probing. So cluster formation will be less if we use double hashing. Okay. So all these are the methods under open addressing where we will try to utilize the memory which we have allocated for hash table. Extra memory is not used. So using open address hashing, table size must be decided in advance. This is the actually limitation. That means proper table size must be decided. Whatever are the limitations of array, they will come here also in hashing. Not applicable for all the applications. Okay, but wherever we need security or wherever we need uh, here in symbol table, faster access is required. Okay, hash tables are used for representing symbol tables, and we need faster access for symbol table. Expectation is we should find the element in big O of 1, but it will not generally happen because of the collisions. Best to guess high, but this wastes space. Okay, so if we allocate too much memory, then spreading of the keys will be evenly, and then collision also will be less. But this will have the limitation of the wastage of space. Okay, then another concept is adaptive hashing, where hash table automatically enlarged and reorganized when it goes too close to the to being full. So when load factor it becomes more than zero point 0.7, then this adaptive hashing might be done. That means table size will be increased and the keys will be again stored properly in the new hash table. Doesn't come to a full halt. Okay, that's why it will never say that the table is full, because it will dynamically increase the memory space. Advantages of hashing. The main advantages over the table data structure, that is symbol table, is speed. Okay, we can access the values in the faster way. This advantage is more apparent when the number of entries is large, thousands or more. So in whatever hash table we have created of 10, 15 values, we will not recognize that uh, advantage of searching. But in the real time, the values are uh, very high. Okay, the number of values which are used is very high, and searching complexity will be known at that uh, moment when the values are high and we are searching one value of that. Hash tables are particularly efficient when the maximum number of entries can be predicted in advance, so that bucket array can be allocated once with optimum size and never resized. Okay, so if we can predict proper size, then it will be useful. The hash table will be very useful data structure. If the set of key value pairs is fixed and known ahead of time, so insertions and deletions are not allowed. One may reduce the uh, average lookup cost by careful choice of hash function. So if we know that keys are fixed, once inserted, they will not be changed again, or they will not be removed again. Deletion is too less. Then hash table is useful, because you have to create the hash table only once. Okay, and then you can spend time on selecting a proper hash function and internal data structures. In particular, one may be able to devise a hash function that is collision free or even perfect, but that needs cost, time, everything. But if you put efforts in designing the hash function, then that will be better. If you need that much security, if you need uh, that much searching. Okay, so if searching is more and deletion is very less, you can always think of using hash table. In this case, keys need not be stored in the table. One advantage of hash table is they do not require sorting. Okay, here we don't use any sorting, but still searching is faster. Not like binary search, where we need the sorted data on which we can apply that binary search. So here it keeps the cost of hash function constant regardless of rate at which items are added into dataset. Okay. So might be during insertion you will take time, but searching is faster. So hashing is another option for searching a hash search. If you have the hash table, then the searching is more faster than linear search or even binary search also. Hash tables, the disadvantages are it is more difficult to implement than self-balancing binary search trees, which we are going to see in the next unit. The another options for hash table for representing the symbol table. Choosing an effective hash function for a specific application is more an art than science. Okay, so the performance completely depends on the selection of hash function. That's why you have to put more efforts on that particular hash function design. In open addressed hash tables, it is fairly easy to create a poor hash function. Although operations on hash table take constant time on average, the cost of good hash function can be significantly higher than the inner loop of the lookup algorithm. Okay, so you have to include the if you are taking too much complexity in creating the hash function, then that time also you have to consider in searching, because first thing is you have to calculate the hash value and then you will do other operations. Okay, and not effective when number of entries are small. For high number of entries, hash table will give you better performance. Okay, with this our third unit is over, but in the next session I would like to go through the program for linear probing with replacement and without replacement. Okay, that program I would like to discuss with all of you. Mm, yes, Ria, we can take 7 also. No problem. Here we have taken 11. Okay. But if you take 7, then again there is a chance of more clusters, because it is, see, it will go to whatever calculated D is there, then D2 plus D, 2D, 3D, like that. Isn't it? So it completely depends, as we saw, it depends on us, how many efforts we are putting in creating the hash function. Okay, the performance depends on that. All the algorithms are where we need to do hash. Okay, hash is the core part of all the security algorithms. Okay, here we are using hash for storing the symbol table entries, but hash is also used in security.